49,000 years ago, in a cave in what is now northern Spain, a man's jaw started to hurt. Day 1, it's just pressure. Something wrong at the back, on the left. Day 3, the side of his face is swollen and he cannot close his mouth properly. Day 6, infection is eating the bone from the inside, and at some point after that, the abscess breaks through the jawbone and leaves a small hole in it, about the width of a pin. That hole is still there. It belonged to a Neanderthal. His jaw is sitting in a research collection right now, cataloged and photographed and measured. A 49,000-year-old man with a dental problem that would ruin your entire week. Here's the thing. You have probably been told that ancient humans had perfect teeth. No sugar, no processed food, no dentists, because none were needed, just clean ancestral enamel, later ruined by us and our snacks. It is one of the most repeated ideas about prehistoric life, and that jaw with the pinhole in it is one of thousands of reasons the idea falls apart the moment anyone looks at actual bone. So what did ancient mouths really look like? The answer is much stranger than the myth. And it starts with a group of foragers in Morocco who never farmed anything, never touched refined sugar, and had teeth that would make a modern dentist sit down for a moment. Their remains come from a cave called Grotta des Pigeons at Tafaralt in eastern Morocco, roughly 15,000 years ago, thousands of years before anyone in that region planted a crop. These were for foragers, living the exact diet the myth is built on. Researchers examined 52 adults from that site. 49 of them had tooth decay. Around half of all the teeth recovered were affected. Not worn, not chipped, rotten with cavities running deep into the tooth. That is a rate you would struggle to find in a modern city with unlimited access to fizzy drinks. So the myth needs correcting straight away. Ancient humans did not have perfect teeth. Some of them had spectacularly bad teeth, with none of the things we like to blame. What they did have was acorns. Enormous quantities of sweet wild acorns and pine nuts, gathered in bulk and stored for the lean season. They were eaten as a sticky paste that clung to the enamel for hours. Sugar never needed a factory. It just needed a tree and a reason to sit still. Picture one of those women in the autumn. She is cracking acorns against a stone, hour after hour, with the whole winter depending on how many she gets through. Her hands are stained, her fingers ache. She eats as she works because everybody does. And the paste sits in the grooves of her molars all afternoon. She is doing everything right. She is feeding her family through a season that kills people. And she is also, without any way of knowing it, running the single most destructive dental routine available in the Stone Age. Acorns were not the only problem either. Honey turns up in the human diet long before anybody farmed anything, and people went to genuinely alarming lengths to get it. In a rock shelter in eastern Spain, there is a painted figure hanging off a cliff face on a rope ladder. One arm is buried in a wild bee nest. Bees are drawn circling around the head. That painting is thought to be several thousand years old, and it is one of the earliest surviving images of a human being risking their life purely for sugar. If you have ever queued outside a bakery in the rain, that is a tradition you inherited intact. Let's back up, because it helps to know what a cavity actually is. A cavity works less like a crack and more like a digestion problem. And you are not the one doing the digesting. Your mouth holds hundreds of species of bacteria. Most are harmless passengers. A few of them happen to love exactly what you love. When you eat something with fermentable carbohydrate in it, those bacteria eat it too. Bread, fruit, honey, acorn paste. Their waste product is acid. That acid sits against your enamel and pulls minerals out of it for roughly 20 minutes after every meal. Then saliva slowly puts them back. That is the entire system. A small war between acid and spit, fought a few times a day. Under normal conditions, it ends in a draw. Now change one variable. Make the food sticky so it sits on the tooth for hours instead of minutes. Or make eating constant instead of occasional. The acid stops resetting. The saliva never catches up. Enamel loses ground and a soft spot appears. Underneath the enamel is dentine, far softer than the surface above it, so the hole widens fast under a tooth that still looks perfectly fine. Under the dentine is the pulp, nerve blood supply, a direct road into the jawbone. That last part is what matters here. For you, a cavity is an appointment. For them, a cavity was a countdown. Farming enters the story next, and it changes the human mouth more than anything before or since. Around 10,000 years ago, in several parts of the world independently, people began growing their food instead of finding it. Wheat in the Middle East, rice in China, maize in Mesoamerica. Nobody coordinated this. It happened on separate continents, among people who had never heard of each other, within a few thousand years. The story usually gets told as progress. In calories per acre, it genuinely was. In teeth, it was a disaster. Compare skeletal populations from before and after the switch, and the same pattern turns up almost everywhere. Foraging groups averaged around 1% of their teeth. Farming groups ran closer to 8 or 9%. Some run far higher than that. Grain is the reason. Ground grain is soft and starchy. It packs into the grooves of your molars, and it stays there. Eat it 3 times a day for a lifetime. And the acid clock barely gets a chance to reset. There is a human version of that statistic, and it is worth sitting with for a second. Somewhere in the first farming generations, there was a child who got the first cavity in their family line. Their parents had no word for it, no idea what it was. They only saw a child who stopped chewing on one side, who flinched at cold water, who woke up crying and could not explain why. Nobody in that village had ever seen this before. And nobody could do a single thing about it. Decay was only half of what farming did. The other half happened to the shape of the mouth itself. Pick up a hunter-gatherer skull, and the first thing that hits you is the jaw. It is big, wide, thick, heavily built. And every tooth in it sits in a neat row with room to spare. That includes all 4 wisdom teeth, fully erupted, doing an actual job. Then pick up a modern skull. The jaw is smaller, narrower, more delicate. The teeth are crowded and rotated and overlapping, like furniture moved into a flat that was measured wrong. So what happened to the jaw? The leading explanation is mechanical. Your jaw is not a fixed blueprint handed down at birth. It is a bone that responds to load, the same way a muscle responds to training. Chew hard things all through childhood and the bone grows longer and wider to handle the work. Chew soft things and it does not. Ancient children were working through tough meat, raw plants, dried fish, and gritty roots. Modern children are working through bread, pasta, and yogurt. One of those builds a bigger jaw. The shrinking did not begin with farming, though. It began much earlier and moved much slower. Line up jaws across the last 2 million years of our lineage, and the broad trend is hard to miss. The path was never a straight line, but the direction holds. Teeth get smaller, jaws get shorter, chewing muscles get lighter. Something outside the mouth was doing more and more of the work. Stone tools that cut meat into manageable pieces, pounding, and at some point fire, which turns a tough root into something a toddler could handle. Exactly when cooking became routine is still argued over, and the evidence for controlled fire thins out the further back you look. The direction of travel is not in dispute. Every technology that made food easier to chew took a little more load off the jaw. Farming did not start that process. It finished it in roughly 400 generations. Researchers have compared jaw shape across many populations. Groups living by farming have measurably different mandibles from groups living by foraging. The difference tracks what they ate, not who they were related to. A separate line of work in the 1980s found that crowded, misaligned teeth were rare in pre-industrial skeletal samples. In the industrial populations that followed, crowding became ordinary. It is worth being careful here, because this is not fully settled. Jaw and tooth size are genuinely inherited, and populations differ. Some researchers argue that softer food explains most of the change. Others think diet is only part of it. Things like how children breathe and how long they were breastfed may matter as well. What the record does suggest is that severe crowding was far rarer before agriculture. It was never absent. That means something slightly uncomfortable about your own head. If you have had your wisdom teeth taken out, and a large share of people run into trouble with them, nothing went wrong with you. Your teeth are very likely a normal size. The jaw they grew into is the part that came in smaller than the space they wanted. You are running correct hardware in a shrunken case. That covers the myth. The next part is less comfortable for all of us. The most common serious dental problem in the ancient world was not decay at all. It was where everything ancient people ate came with grit in it. Grain was ground between 2 stones, and the stones shed fine particles into the flour with every push. Roots came out of the ground with soil still clinging to them. In desert regions, wind-blown sand landed in everything, including the bread. Egyptian mummies show the result clearly. Their molars are frequently worn flat, straight through the enamel, sometimes into the dentine, and occasionally all the way into the pulp. Picture chewing a slice of bread with a teaspoon of fine sand mixed into the dough. Now do that twice a day for 30 years. That is the situation. And when the wear reached the pulp, the outcome was the same as an untreated cavity. Infection entered the jaw, the face swelled, In the worst cases, the infection spread into the soft tissue of the neck or upward toward the brain. People died from this. Not dramatically, not in any way that got recorded. Just a person who had a bad tooth, then a bad week, then no more weeks. Decay and wear were not the whole list, either. Gum disease turns up constantly in ancient jaws, and it leaves a signature you cannot miss. The bone holding the tooth socket retreats. The socket gets shallower and shallower. Eventually, the tooth has nothing left to sit in, and it comes out of a mouth that looks otherwise healthy. In some ancient populations, a person in their 40s has already lost a serious number of teeth this way. Not from violence, not from decay, from the slow, quiet retreat of the bone underneath. Losing molars had consequences that reached a long way past the mouth. Chewing is the first stage of digestion, and somebody who cannot grind their food properly gets less out of everything they eat. In a world with no soft options and no spare calories, that compounds fast. Lose enough teeth and you are quietly on a worse diet than everyone around you, eating the same meals at the same fire. One particular skull makes that very hard to look at neutrally. It comes from a site in Georgia, in the Caucasus, and it is roughly 1.7 million years old. Almost every tooth is gone. The sockets have fully healed over, and the bone has remodeled, which means the tooth loss happened years before this individual died. Somebody who could barely chew anything survived for years anyway. Researchers still debate what that implies and how far to push it. It is difficult to read that skull without concluding that other people were involved. There is one strange upside to all that grinding, and it explains part of where the myth came from. Heavy wear flattens the chewing surface of a molar and takes the deep grooves with it. Those grooves are exactly where decay likes to start. So a mouth full of teeth worn down to smooth stumps genuinely does get fewer cavities. When you look at a skull like that, the first impression really is clean, strong ancestral teeth. The teeth are clean because they have been sanded down for 40 years by a diet with rocks in it. Wear tells you about more than food, as well. Look at Neanderthal front teeth, and they are often rounded and blunted in a way that ordinary chewing does not explain. Put them under magnification and the outer surface carries fine scratches running at an angle across the enamel. The pattern matches something very specific. Somebody grips a strip of hide or sinew in their front teeth, pulls it tight with one hand, and cuts downward past their own lips with a stone flake in the other. Every so often, the blade slipped and caught the tooth. Their mouths were not only for eating. Their mouths were the third hand, and the enamel kept the receipts. The angle of the scratches even suggests most of them were right-handed. Which raises an obvious question. If ancient people were living with this, did they try to do anything about it? They did, and some of it is startlingly early. Small curved grooves show up on the sides of hominin teeth going back hundreds of thousands of years. At the exact point where two teeth meet, they are toothpick grooves worn into the enamel by something being pushed between the teeth over and over. Not once. Habitually, for years. Somebody had a sore gum and a stiff piece of grass stem and a daily routine, and it wore a channel into their own tooth. Then there is the site of Mehrgarh in what is now Pakistan. Around 9,000 years ago, someone there was drilling teeth. Researchers found 11 drilled molars from 9 different adults. The holes are neat, between 1 and 3 millimeters across, and the walls carry the concentric marks left by a rotating point. There is wear inside the holes, which tells you the people kept using those teeth afterwards. They were alive when it happened. Sit inside that scene for a moment. A man lies back with his mouth open. Someone he has known his whole life is holding a flint tip mounted in a bow drill, the same tool the village uses for making beads. There is no anesthetic. There is no way to stop halfway. His only job is to stay completely still while somebody grinds a hole into a living tooth. He is doing it because the alternative is another month of the pain that got him here. We do not know whether it worked. We know he was still eating with that tooth afterwards. About 6,500 years ago, in what is now Slovenia, somebody with a badly cracked canine had beeswax packed into the crack. It is the earliest known filling. Whether it was placed during life or right at the moment of death is still debated. The wax is real, though. It is in the crack, which brings us back to the man in the cave, in northern Spain, and the pinhole in his jaw. Researchers analyzed the hardened plaque still stuck to his teeth. Inside it, they found traces of poplar, a tree whose bark contains salicylic acid. That is the compound aspirin was built out of. They also found a mold from the penicillium family. The team that published this proposed that he may have been self-medicating, chewing poplar against the pain in the jaw that was slowly destroying his bone. That is a hypothesis and not a settled fact, and other researchers have pushed back on it. Poplar could have entered his mouth for reasons that have nothing to do with pain, but if the interpretation holds, then a Neanderthal with an abscessed tooth was chewing bark containing the same compound you reach for when your head hurts. 49,000 years before the pharmacy. Same molecule, same problem. Considerably worse afternoon. The last chapter is the shortest and the most recent. The bacteria of the human mouth have now been sequenced from hardened plaque spanning thousands of years, and two big shifts show up in the record. The first arrives with farming. The second arrives with the industrial era, when refined flour and cheap sugar stopped being luxuries and became everyday food. After that second shift, the modern mouth gets less diverse. The species most strongly linked to decay become dominant in a way they were not before. So the ecosystem living in your mouth is genuinely different from the one in a forager's mouth. Fewer species, meaner ones, much better fed, and yet, the myth gets one thing exactly backwards. Your teeth do decay more than a forager's did in most cases. Your teeth also last far longer. In plenty of ancient populations, adults were losing teeth in their 30s, and empty sockets that healed over long before death are one of the most common findings in ancient jaws. A modern person with 3 fillings has a mouth that is technically more diseased and functionally in far better shape. The problem never got solved. It just stopped being fatal. There is one more piece of this, and it flips how you think about your own mouth. For decay, the amount of sugar matters far less than how often it turns up. One large dessert eaten in 10 minutes hands your saliva a single acid attack to recover from. The same sugar sipped slowly across an afternoon hands it 6 or 7, with no recovery time in between. Most foraging diets ran in bursts. Honey in season, fruit when it ripened, then long stretches with nothing sweet at all. The modern default is a small amount of sugar arriving more or less continuously, from breakfast until bed. The ancient pattern was a few hard hits with long gaps. The modern one is a siege, and the thing that genuinely changed is more recent than sugar. For most of human history, a bad tooth had exactly one endpoint, and the only open question was how long it took to arrive. Extraction without anesthetic existed, and it was every bit as bad as it sounds. Within roughly the last 2 centuries, that stopped being the situation. Our teeth did not improve. Somebody finally worked out how to stop the pain and clear the infection before it reached the bone. You belong to the first few generations of humans who can have a serious dental problem and simply never find out how it ends. That changes what your bathroom mirror is showing you every morning. The row of teeth you see there is mostly a record of 2 things. What you chewed before you were about 12, and what your species started eating around 10,000 years ago. Your enamel finished growing in childhood, and it does not regenerate. So whatever is on it now has been accumulating since then. The jaw holding them keeps growing into the late teens. But most of the loading that shaped it happened long before that. Every soft, convenient meal of your childhood was a small instruction to that bone about how much room to build. The toothbrush, which feels like the main character in this story, is a very recent arrival. Brushing your teeth in anything like the modern sense is barely a couple of centuries old as a mass habit. For almost the entire run of human existence, dental care meant chewing tough food and wearing your molars flat, and hoping. There's one more thing you already share with them. That flinch you get from very cold water on one specific tooth. That is dentine, exposed where the enamel above it has thinned and the nerve underneath reacting to temperature. It is the exact sensation that the child in that first farming village could not explain to anybody. Same nerve, same signal. About 10,000 years of difference in what happens next. So back to the jaw in the research collection and the pinhole in the bone. We can date it. We can scan it. We can read the plaque on his teeth and name the trees he chewed on. What we cannot recover is the only part that mattered to him, which is how many nights it kept him awake, and whether anybody sat up with him. The perfect ancient mouth was never real. What was real is that the pain was identical to yours, in the same tooth, in the same spot. He just had nowhere to take it. So the question worth keeping is not whether his teeth were better than yours. They were not. The question is what you would have done in that cave on day 6. Subscribe, because next time we take something else everybody assumes about ancient humans and check it against actual bone, and leave a comment with the worst tooth pain you have ever had. Somewhere out there is a Neanderthal with a poplar branch who would like you to know that he understands completely.